Everyone, we will solve this today's LeetCode problem. This is LeetCode medium. The question is distribute coins in binary tree. Here we have given the root of a binary tree with n nodes, where each node in the tree has node.value coins, and there are n coins in total throughout the whole tree. In one move, we may choose two adjacent nodes and move one coin from one node to another. A move may be parent to child or from child to parent. So we need to return the minimum number of moves required to make every node has exactly one coin. Okay. So here we have given the n nodes, and total number of coins in whole tree should be n coins, right? So we need to distribute as how that every node should have one coin at least. So, and we can move, we need to take a minimum number of moves to make this happen. So in one move we can choose one node, two nodes, and move one coins from that node to another node, right? So that is the only one move we need to require. So the first thing which came in my mind is that how we will uh, find the minimum number of moves. So that how can we simply distribute the whole coins in at least one coins to each of them, right? So suppose here in this example, if we see that the root node has three coins and its child has no coins, right? So it should store one coin to itself and left two coins. So it has a two extra coins. So it will distribute to its siblings or its child. Sorry, its child. Then it should have given one and one to each of them. So it takes two moves total. So if we see the second example, here three coins is at leaf node, and its parent and its siblings has zero nodes. So it has to distribute one coins to each of them. So for that, he need to move one coins to each of them. For its sibling, it's need requires two moves, and for the parent, it required only one move. So total value is three. So after reading this question, the first thing which should come in your mind is also that the first thing we need to find out how we'll move these coins simply, right? So let's take an example. So suppose this is two, right? Suppose this is two, and this is its siblings is one. Its siblings is one, and this is okay. Or we can see here that the total number of nodes is 100 only. Okay, so we can move in all the nodes at once, right? At once or two times, right? So if suppose we take examples like this, where we make a random tree by mixing of all the coins, right? So this is total three. So take it zero and also take it as, I'm just assigning random row, and take it as two again, right? So how many total coins are there? Two plus two, four, and plus five. So we can make at most five nodes. So one, two, three, four, five nodes, right? So if we see here, the parent node has two nodes, right? So he can transfer this zero, one coin to this zero, its child point. So it will take a move of one, right? It will take a move of one, and this will get assigned to one, and this will has one only. If we see zero, here one has only one coins, it has no extra coins, so it cannot give any coins to this. But this can give a coins to this. So this has two, so it will take a two move to give this coins, so total move is three. But if we see, this 2 can also give the 0, and this 2 can also give the 0, but the total number of moves which they take, it will be greater than this 3, but we want minimum number of moves, right? So the first thing is clear that we need the nearest source of coins, which the nearest extra coins, where uh, we can we can differentiate we can successfully uh, fulfill this differentiate coins to this child, right? The first thing is we need to find the nearest node which has extra coins to fulfill the requirements, to fulfill the deficiency for that node, for current node, right? Right. Okay. So the one thing is how we will traverse, because it's a tree, so it must be traversed anyhow. So we have three types of traversal. We have three three types of traversal, right? The first is pre-order, post-order, and the in-order, right? We have three types of traversal. Okay. So if I try to implement pre-order traversal, so first thing is that how we will distribute this thing. So suppose I go started with this two, I have extra one coin. I move to this its children's. So if I made this route as a manager or as a parent, that it's requirement, it's the duty of parent to distribute the coins equally to its children's, right? So it's two parents, its children, left part is here and right part is here. So its parents duty to distribute the equal coins to to their children, right? If you understand like this, it's parents requirements to distribute children's like this, right? So the one thing is clear that we need to we need to track we need to track the number of extra coins, and moves both, because ultimately we need to return the number of moves here, and number of moves will depends on extra coins, right? Which will we move. So we need to track both of this simultaneously, right? The one thing's clear. So if I see here, it's a parent's duty to make the distribution equal, right? So if I start traversing from route, so I will go to its left, right? I will go to its left and check that whether it have as a requirement or not. So this route will again check to its children, that whether this its children should have it has requirements or not. So we are moving in left direction, right? This parent will go into the left part. So this zero will tell that I have requirement of one coin, right? This will send this will tell that I have requirements of one coin. It means, can I send -1 to this? So because it is a leaf node, so it has don't have a children, right? So it has requirement of zero, one coin. So it will tell this parent that I have required my one coin. So can I send this -1 to here? Can I send -1 to here? Can I send? Right? Okay. So when this parent go to the right child, it will tell that I don't require anyone, but I have an extra coin. So it will return one extra coin to this. It will return one extra coin to this. So the right part gives one extra coin to this parent, right? Okay. So this -1 and this, okay, so, just a second. This -1 and this one is came from his children, right? So this one is extra from right child, this one -1 is uh, deficiency from left child. So it's parents duty to equalize it. So this one can be utilize this to -1, right? So it will be equalized, but how many moves are there? So if you see, from 2 to 1 there is one, but from 1 to 0 there is another move. So both are equals to 2 move, right? Both are equals to 2 move, right? So if you see, if we add this 1 and absolute value of this, it will also coming to 1. If I take left values 1 plus right value minus requirements -1, it will also take 2. If you see here, because the number of coins which they require, that much coins need to be moved from this part to there. So the number of coins which try to move is from 2 to 0, and this from 0, and so that will be equals to moves also. But after this one, it equalizes both of them, right? So after this equalization, the one has left how many nodes, how many coins, extra coins? 0 coins, because this -1 and 1 will equalize both of them. So the one will have only 0 coins left. The one will have 0 coins left. So what will it return to its parent? So what will it return to its parents? 0 coins. It will return 0 coins to 2. So the the parent of 2 has left children 0 coins left, 0 coins left. But when it goes to 0 part, how much coins it will require? It requires -1 coins. because it will tell na ki I don't have, I have 0 coins, I need 1 coins. It means it requires -1 coin. So this -1, this 0, and this 2. So this root has an extra coin, because it should have only 1 coin, but it has extra 1 coin. So it can give -1 to this, right? This can give -1 to this. And how many moves it will take from 2 to 0? For moving from 2 to 0, it takes only one move. So if you add again this -1 and this 0, if you see that the number of moves again becomes 1. The number of moves again becomes 1. So absolute 0 plus absolute -1 is actually giving us 3, because this 0 and 2 it is giving -1 and is 3. So this will gives -1 to this. So ultimately what we are returning, right? So we are returning the number of coins, and we are storing answer in our. So if you see, we are going from left, then right, and then root. So left, right, root. Which traversal is this? This is pre-order traversal. Sorry, this is post-order traversal. This is post-order traversal. So this is just like the post-order traversal. We need to just find here that how we will move in this parent. So this, how we will go to this approach. So I need to equalize this thing. So I need to make something as a center point, so that it can equalize both of this. So I maintain a parent. I maintain a parent so that its parent duty to equalize its left and child right child, and return some number of coins which is extra to their parent. So if I take any other example, suppose let's take 2, then this 0 or something. Let's take 0 or something like, uh, let's take it as a 0 again. Let's take it as a some big example, right? So let's take it as a 0 again, and this again, right? Let's take this as an example, and make it as also again 0, and this will be uh, this will be again 2, and this become 3. Let's suppose this is 3 given, right? Or take it as a 3, and again mark it as 1. So this is 0, and this is comes as a 2, right? So total coin number of coins is 3 to 5 plus 7, and total number of nodes is 3, 3, 6, and 7, right? So both are equal. So now if we follow the same approach, left right route, post order traversal, left right route, then we are moved to its left part, then it moves to again left part. Its left part will give, it requires one coin, so it will ask its parents to give it -1 coin, right? It will return, it will give parent, tell parent that i need I need -1 coin, right? I have -1 extra coin. If we go to right, it will also ask that I need also -1 coin, right? I need, sorry, I require, I can give -1 coin, it means I require 1 coin, right? So uh, okay, let's write this in this here, because there are some space constants. Space. Right. Yeah, it's working. Yeah, fine. So this both requires -1 coins, right? So it has total -2 coins. Now this parent has also, his parents has also no any coins, right? So how many moves they requires to this parent? Till this parent they require two moves. till this till this parent, they require two moves from this 0 to this 0, this 0 to this 0. So total two moves required, right? And what will this parent return to this parent? This will return -3. Why? Because this both parent needs -1, and it also required a coin. This both parents, children's all requires one coin, so it will return -3 to its parent, that I need 3 coins. I need 3 coins So this tool know that its left part requires my 3 coins, right? Now it will go to right, so 3 will go to right, and now 3 will check to its left part. So it will tell that I need -1 coins, and when it will go to right part, it will tell I have sufficient coin, I can give 1 coin. So it will give 1 coin. So how many move they require now? So they require -1 plus 1. It means absolute value of -1 is 1 and plus 1 is 1, which is 2 again. Why we are taking absolute value? Because for calculating moves, I need the number of coins they require, so that I can move it from there. So I can move 1 coin from 2 to 3, then 3 to 0, which will require this one move from 2 to 3, and my one move again from 3 to 0, which is -1. So that will be taken as absolute value, because we need to add it, right? So this 3 will return what? This -1 plus 1 is 0, plus this 3 has also 2 extra coins, because it will keep 1 coin, right? So what will it return? So 3 minus 1, which is 2, plus this -1 plus 1, which is again 2. So it will return 2 coins to this parent 2. Now this parent has left children 3 and right children 2. So how many moves it will take? -3 plus 2, which is equals to 5 again. So it will give us again 5 coins. So what will give? 2 plus 1 is 3, plus 1 is 4, plus 2 is 6, plus 3 is 9. And what is the sum of this 3? It becomes again what? 1, absolute 1, because -3 plus 2 is -1, and -1 plus 2 is +1. So 1 coins is required to this parent. So total number of 9 to make this as a distribution equally. So if you see randomly, manually, it will take comes to 9. So see, this 2 will give to this 1. So 2 plus 1 is 3. Now this 3 will give 1 coin to this, or anything. So 2 plus 1 is 3. 1 2 3. 3 3 is 6, right? 3 3 is sorry, 2 plus 1 is 3. 2 plus 1 is 3, and right. So this 2 will give this 2 coins. So this is 2, and this is 2 4. This is 4, and okay, sorry, this 2 will give me only 1 now. This will not give 2 coins, this will give only 1. So this will give only 1, so this can give to this or this, right? So it will take 2 moves to give 1 coin to this. From this 3, it can give to this and this also, right? From here 2, and this is 1 2 3. So 3 plus 2 plus 5 plus 2 7, and plus from this 2 to 0, it is 9. So total comes to 9, right? So this is how we will solve the questions. Solve this question, right? This is how we will solve the questions. So basically what we need to do, we are traversing, we are using pre or post order traversal again. I don't know why I'm telling again and again pre-order. It's post order traversal. The same mistake I have done yesterday also. So we are using PostOrder Traversal and keep tracking of moves and returning the number of extra coins from child to its parent. Right, right. So this thing we are doing, right, and also we are returning -1 when we have 0, but because this need a one coin, so it has a deficiency of 1 coin. So I need 1 coin, so I returning -1 to give me an idea about that how I need this much of amount, right? So this is how we will solve this question. Let's try to implement this. This is just a post order traversal, but the trick was here that we need to simultaneously track of extra coins and extra moves both, right? So I hope so this will work. Let's try to implement this. So let's take a answer, and and let's take a solve function here, which will give me the number of moves and coins, and this will be answer, or let's take it as a variable. Okay, let's take it as answer. And also I need to keep track of number of coins. So for that I need to move in this. Let's take it as a voice solve tree node root, and this is an answer. This is for move, this is for number of moves. And okay, I need to also return the number of coins which it required, so it should be traversing this, and this is coins, right? Okay, now the first thing is I need to move in left, then right, then root. So I will move in left, then right, right, and then I will make some process on root part, right? We are moving left and then right, and we are taking some right part. So one thing is here that if my root is null, then what will return? We will return the number of coins, which is zero, because if root is null, then we have don't have any coins with it, so we will return zero part. Now the first thing, if so the first thing is here that answer should be what? So if you see here, when we are at leaf node, so this 0 is at leaf node, so its children will give me 0, its children will give me 0. But this require a one coin. So what will is it ask to its parent? It will ask that I need a one coin, and my childrens have 0 coins. It means, and what will its move? So it have 0 moves, it have 0 moves. So the first thing is here that I need to take the absolute value of this left part and absolute value of its right part. And what I need to return? I need to return the total number of coins which has the current points minus 1, because every node wants 1 coin. So if you see here, this is the leaf node, right? This is the leaf node. But if you see here, it its left part, it requires minus 1 coin, its right part requires minus 1 coin. So this left part and this right part have minus 1 for this current node. This node, its left part have minus 1, and this right part has minus 1. So total number of moves, what will be? It will be absolute value of minus this two whole, that is 2, right? That is 2. So that's why I take the moves summation through this, and I need to always add this again and again, because I need ultimately this total number of moves. So I need to add this, not equalize this, right? And what I need to return this from 0 to the its parents total number of coins. It has extra coins, or it demands extra coins, so it will return minus 2, and it also requires 1 coin. So the total number of coins it has minus 1. So it requires my total number of coins. So it has left plus right, plus right, plus it has a coin value minus 1, because it can be possible that it has deficiency, or it can be possible it has extra coins. So if 3, if you see 3 node, it will require a 1 coin, so it will return, it can give 2 coins, and its node has minus 1 plus 1, so 2 minus 1 plus 1. So that's why I have written root value minus 1 plus left plus right. And for calculating moves, I will take absolute value, this, right? So this is how we will solve the question, and at last I will return an answer. Simply, at last I will return an answer. And why we have taken by reference? Because it will update again and again my total number of moves. That way I have passed it by reference, right? So this is how we will solve it. Let's run this. I hope so. This is implementation is much more similar, but the trick is here that you need to keep track of moves and coins. So you will return number of coins it required from its children to parent, and the total number of moves added accordingly in the path of that, right? That's the thing. Sample test case has passed. Let's submit it. Let's try to submit it. Yeah, it successfully passed. So time and the space complexity is, so time complexity will be O of n, because we need to traverse in whole tree, and the space complexity will be 0. Sorry, 0, I mean O of 1, because so this O of 1 is auxiliary auxiliary space. We are not taking any extra space for that, but it has a recursion stack space which is equals to n, because I need to move for each and every n. So it will take recursion stack space O of n. So overall it is O of n space complexity. So this is the time and the space complexity it has. So this is how we will solve this question. So it's just a post order traversal, right? How we figure out? Just by taking example. And so it's a tricky one. If you have solved this problem, this type of problem before, you will able to figure it out. Or if you're not able to figure it out, you will next time, if you see like these questions, you will simply got click that this is how we will solve these questions, right? So if you find any tree questions, you just to apply pre-order, post-order, in-order traversal, and do something on this, and we will be able to solve all the tree questions, right? So this is how we will solve this question. Thank you. Bye bye.